Hi, everybody. I hope you had a great weekend. Just want a quick review of the big ideas in this chapter before we get into a sort of a little tiny mini lab. First of all, electrical concepts. Remember that charge, usually represented with the variable Q, is represented in coulombs. Current, represented by the variable I, is used, or the unit is the ampere, or coulombs per second. Electrical potential, represented by capital V, the units are joules per coulomb or volts, abbreviated small or also capital V. And then resistance, usually represented by the variable capital R, is measured in ohms, which is abbreviated with capital omega. Charge is like volume, current is like flow rate, electrical potential is just like water pressure or air pressure, and resistance is like flow resistance. So where am I leading you into? Well, today's lab, you're going to be using a nice HTML lab online. You'll find the links. And if you start it up, you'll see you're actually going to be able to design circuits. And this should work no matter if you've got a phone or whatever. It'll work in anything. First of all, a couple of changes I need you to make beforehand. We're going to use conventional current. That's the Ben Franklin's current. That's about all we need to change to begin with. So how do you use this? You literally drag things around. The first part here, I want you to drag a battery, and you can move it around wherever you want on the screen, doesn't matter where. And I want you to take a light bulb as well and drop it in here. The light bulb has a connection here at the bottom and the side. And now I need you to add an amp meter. Amp meters, remember, or actually I haven't talked about it yet, an amp meter measures amps, which is electrical current. Now, because it's measuring the flow rate, the current has to flow through the amp meter to actually be able to measure it. So I'm going to put it so that the current from the battery flows through it here to the light bulb and back again. And now let's go ahead and connect our circuit. So I'm going to grab a wire, drag it over, make sure one end connects there and one end connects there. I'm not really happy where the amp meter went. Let's move that there a little bit. You can cut it if you want, but I'm happy with that. And now I'm going to drag another wire over here between the amp meter and the light bulb. And let's move the light bulb down a little bit too so it looks pretty. And then a wire down here. Now notice that there's no current flowing yet in the circuit. Why? Because you haven't completed it yet. We've got to have a complete electrical circuit before that happens. And just to give ourselves a little space here, let me bring it over here. And then finally drag a wire here. If you put it nearby there, it'll click there. Oops. And then grab this end down here, and voila. There we go. And we've got a complete circuit. Notice light bulbs lighted or lit. Lighted. And we've got a complete circuit. And there's 0.9 amps. So in other words, 0.9 coulombs per second flowing out of the battery. You might say, well, why does that happen? Well, if you click on your battery, you'll discover that it's set at 9 volts, and you can change that later. And if you check the light bulb's resistance is 10 ohms. And if you remember Ohm's law, which is I equals V over R, 9 volts over 10 ohms gives us 0.9 amps of current, which is exactly right. Now, one other thing I want to mention real quick, you don't have to do this in your lab, but I just want to show you. If I remove this wire, I'm going to click on delete, and let's put in another ammeter here. What's the current after it's gone through the lamp? And if you remember, I told you last time, but I want to show it to you again just so you can really get it. What's the current afterwards? It's still 0.9 amps. Why? Charge can't be created or destroyed. All the battery does is pump it and increase its pressure. And the volume of water, or the rate of flow, which is current, there's 0.9 coulombs of charge leaving the battery, and there's 0.9 coulombs of charge per second entering the battery. These have to stay the same. What's being used up in the light bulb? The energy that the battery gave it. So in this case, you can sort of see what's happening. Now, there's one other device I want to show you as well, and that's the voltmeter. And you can drag it across over here. And what the voltmeter tells you is the difference in the electrical potential. How do you use it? You literally can drag these two leads and put them anywhere you want. If you put them on the battery, you'll notice that the potential difference between the top and bottom part is 9 volts, just what you expect. And now take a look what happens if you put it across the light bulb. I'm going to put the positive lead there because it's close to the positive lead of the battery, and put the negative lead over here. And notice that it's reading a potential drop of 9 volts. What's happening? The battery's increasing the potential by 9 volts, and then the battery's dropping the potential back down to 0. Finally, if I use this as my reference point, you can actually check the potential different points. Here it's 9 volts. Here it's still 9 volts. After it goes to the light bulb and loses the 9 volts, it's down to 0, 0, 0, 0, 0, 0, all the way back around. So you can do some quick measurements. In the first part of the lab, I guess I should put it back, you don't need to put an amp meter down here, but what you're going to be doing is changing the voltage of the battery and measuring the potential across the light bulb and the current in the circuit as you change it. Then you're also going to be changing the resistance of the light bulb and measuring what happens to both of these quantities as well. The second part of the lab gets a little bit more exciting. Let me just reset everything. Second part of the lab, what you're going to be playing with is what happens if you put light bulbs in series and parallel. Well, first of all, in series, no big deal. You're just going to have to, it's not going to be pretty. Add in some wires here. Oh, I guess I should put an amp meter in right away before I get carried too far away. So sticking in an amp meter, oh, come now. I don't know if I've got it. Oh, it is connected. Okay, good. Sometimes it's hard with short wires. So if you're putting light bulbs in series, you can just do, and then that one over there, and then this one here to connect one there, grab the other end there, and then back around. And yeah, I know you could make it much prettier than this. I could move my light bulb to make it prettier. Move this light bulb down to make that prettier. Oh, hold on. There we go. And then a little wire over here just so we're not right on top of the other one. And then a wire down. Dink. Dink. And then connecting it there, we get our circuit again. Well, guess one thing. Oh, sorry. Conventional current. Thank you. That looks better. And if you stuck an amp meter in the middle of this, you would discover that, ironically, the current stays the same. If I can connect it, there we go. The current doesn't change, but now if you do your voltmeter, you'll see something interesting. If you measure, all right, I should explain first of all, our battery is at 9 volts. What's the potential drop across the first light bulb? Well, if you check it, you'll discover, it loses, I got my leads backwards here. That should be the negative end. That's a positive, not that it matters. It loses 4.5 volts there, and then it loses an additional 4.5 there for all of the 9 volts it had. So you can sort of watch and see what's happening. I guess I probably should show you real quick what happens if you put light bulbs in parallel. How do you do that? Well, it's not too bad. I'm going to put them on top. I don't know which way is best in this case. I guess I'll do it this way. So, sorry, light bulb. Oh, great. Now I'm rotating it. Tell you what, I'm going to delete that. Whoops. Bad. My bad. Sorry. I didn't realize you could twist light bulbs around. I should play with that. Let me do that one more time. So how did I do that? Tap to edit. Can I rotate it now? Nope. Okay. If I use the arrow keys? Nope. Okay, never mind. I don't know how I did it. Let me know if you figure it out how to do it. And so to put light bulbs in parallel, you're going to connect both their bottoms together and then both of their sides together. And that's a little bit tricky, but not impossible. I'm going to do whoops. Now, I'm going to do a series of wires so you can sort of see what's happening here. And connecting one end down to here, one end up to here. Grab another one here, one end down to there. Sorry, this is kind of ugly. But I wanted to show you what it looks like so you're not completely confused when you get to it. Adding my battery, dragging one end around. That's probably how I would rotate the light bulbs. That would make it easier. Maybe I'll do that in the lab instructions. How do you hook it up? we're going to take one end of the battery, and it's going to connect to both the sides. It doesn't matter which way we draw or have the batteries connect or the wires connected. And then one wire from down here connected to the other end. And so now current goes from the battery, it splits. It can either go for this light bulb back or this light bulb back. And again, you can measure the current in this and the voltage drops, and that's the second part of your Ohm's Law lab. Hopefully I'll get you started, and you should have a fun time with this. It's a fairly easy mini lab. Have a good time, and we'll talk to you soon. Bye.